Hi class, welcome again to another session on rehabilitation engineering. So we have been discussing the principles of ergonomics. Now there are two more principles which are left which we shall discuss in this video. The first one is principle of adaptability and flexibility. Now, when you are developing an assistive device, you have to bear in mind that the end user is going to get used to using your device, and there are chances that he or she may improve or they may develop additional skills over a period of time. So you can't say that whatever their condition is today is going to remain their condition for the rest of their life, because that would make rehabilitation and assistive technology meaningless, right? So the device that we develop should be able to take some sort of feedback based on the user's performance and try and improve it, right? So an effective feedback mechanism should be employed to allow the device to learn from the user's requirement, or periodical checks should be made so that if any upgrade is required, then that could be done so that the user's learning curve keeps on improving and they would be able to use a device effectively based on their current requirements. So that is the main principle of adaptability and flexibility. Now the last principle is principle of mental and chronological age appropriateness. This sounds like a really, really big name or really, really big principle, but it is vital to understand our end patient population group. By that, I mean to say that sometimes the patient or the user who's using a S device would have grown physically, but their mental development wouldn't be, at par with their physical age. For example, if you see someone with cerebral palsy, so although they might be age 10 or 12, but their biological age might be 10 or 12, but their actual behavior wouldn't be same as that of a 10 or 12-year old, right? So, as a rehabilitation engineer, we should make sure that we consider their physiological or their functional age rather than their biological age. So with users such as these who have reduced information processing capacity, our as the assistive device that we are suggesting would still be beneficial to them. So, as a rehabilitation engineer, it is very, very important to consider the functional age and the fact that they have reduced information processing capacity and suggest a device that is, simple and straightforward for use. That is, suggest a device that this particular individual can use effectively. So that is a major requirement as a rehabilitation engineer that we should adhere to. Right, so some guidelines are available which should be taken into consideration while developing a device for an elderly. So, if it is a young individual who has mental, like who is mentally not at par with their physiological age, so they should be, we should assess that. At the same time, as a person grows, he or she might have some disability or some illness because of which they might not be able to process information very well. Now, one example is someone with Parkinson's, right? So, if someone has Parkinson's, then they do not respond very well to instructions. So, they respond to cues. So, all these considerations should be kept in mind while you're developing a device for an elderly. So, some of the guidelines that are listed are: strengthen the display signals by making them louder, brighter, and larger. Because as you age, there are chances that your vision and your hearing capacity might deteriorate. So it is necessary that you make the signals loud enough so that an individual can hear it, or you make it large enough so that a person with visual issues might be able to visualize it as well. Then simplify the controls and display to reduce irrelevant details that could act as a source of confusion. Give them exactly what is required, right? Don't give them anything extra. Don't feed them with extra information because that might lead to confusion. Too much of information can be hazardous as long as an elderly person is concerned. Just let them know exactly what needs to be done in order to do which task, and then they'll be fine. They'll be able to use your device as a pro. However, if you just try to sit down and explain to them for hours and hours, then there's very, very good likelihood that they'll get confused and they wouldn't be able to use the devices effectively. So that is something that should be borne in mind while dealing with elderly. Then you have to maintain a high level of conceptual, spatial, movement congruity. That is, you have to make sure that there is a compatibility between the control, the display, and the device response. For example, let us take the example of using a joystick, right? So joystick, you can either, like if you're using your hand to move a joystick, you can either use it to move forwards, backwards, and sideways, right? So if you are like having a device that is able to like has got a complicated operation, or you have wired your wheelchair such that forward movement of joystick would result in reverse movement of the wheelchair, and backward movement of the joystick or downwards movement of the joystick would result in forward movement, right? So that is going to confuse them. We are so used to follow our hand we're so used to connecting the hand movement towards the direction in which we want to move. So assuming that we want to move forward, we want the joystick such that we want the program in the joystick such that if we push it forwards, then our wheelchair moves forwards. That would be the best possible way to describe it, right? So this is what you have to have: a compatibility between the controls, the display, and the device response, right? If I'm pushing my joystick forward, I expect my wheelchair to move forwards, and that should be the way it should be done. So this is your third guideline. Fourth one is to reduce the requirements of monitoring and responding to multiple tasks. So when the particular individual is using a device, you want them to concentrate on the task that they want to do rather than what they need to do with the device, or how are they going to manage, or how are they going to multitask between them. So our device should be such that the individual can use it with reflex action, so that majority of the concentration is done towards performing the task rather than operating the device, right? Now the next one is provide more time between the execution of a response and the need for the next response. Where possible, let the users at the pace of the task. Exactly. Now, you see, even with so-called normal individuals like you and I, we all do things at our own pace. I mean, I, for example, do not like to be pressurized. If I'm given too much work to do at simultaneously, I would, I'd slow down and I'm more prone to make errors. However, if you just tell me that, okay, these are the tasks that you need to do in a week's time, then I probably think over, prioritize which work needs to be done first, and then, do it on my own pace. So that is something that is how I work, and I'm sure, like if you have a disabled person, if you just rush them through certain things, then they don't respond very well to it. This is from my clinical experience. And the last guideline says allow more time and practice for learning the material or the task to be performed. Which is, you have to give the individual time. You just can't expect them to nail a particular activity by just few attempts. They have to have this confidence that yes, I can do this task and I can do it as a pro. So you give them as much practice as required and let them decide exactly when they are ready rather than you deciding when they should be ready. Right? So these are the principles of mental and chronological age appropriateness, and that winds up our ergonomic principles. I hope you had a very, very fruitful session learning about ergonomic principles with me, and I shall see you again with another video soon. Till then, take care.